Hey everybody, today we're going to do part 2 of our math TEAS review. So we're going to jump right into it, keeping in mind that everything we're going over is really fairly easy, but the reason it is so tricky to so many is that it's unfamiliar or they just haven't had it in a while. But just remember that everything in this section is really not meant to be difficult, it's just unfamiliar. Okay, so first thing we're going to talk about is something called rational and irrational numbers. So this is something, again, right off the bat that is probably unfamiliar to many unless you've had, math in the very, very recent years. And even then it might be unfamiliar. But what a rational number is basically any real number or basically a whole number. It can be a fraction. It can be a decimal. Right, one that it could even be a repeating decimal. Okay, so I'll give you some examples of how they might ask for these rational or irrational numbers. And what they're going to do is they're just going to give you a number. Obviously, a number like that is considered rational because it's just a regular old real number. Okay, they could say, hey, square root of 49. 7 times 7 is 49. So that would be 7. That's still a rational number, right? 0.25 or 0.5, whatever. Those are rational numbers because they're just regular decimals. Even if it was a repeating decimal, okay, it went on forever, but it basically wasn't some off-the-wall number that basically was non-repeating. If it's a repeating decimal like that, it's still a rational number, okay? What would not be rational? Anytime we're asking for a square root that isn't going to have a real number in it, okay? So this, just throwing this out, that would be what we call an irrational number, okay? What would also be an irrational number? A number I just made up here that basically goes on forever but isn't repeating, it's just random. Okay, that would be, and they'd have to put it like this and put literally the dots after it so you know it's going on forever but it's not in any particular repeating sequence. That would be an irrational number. Okay, so I think, and I could be wrong, but I think you've got more examples of rational here than irrational. I think, if in doubt, I would probably go rational if you just didn't know what it was. But basically, you've got to have a real number, a decimal, something repeating. 0.55, in case you don't know, it just means 5 goes on forever, right? Something that you can't work out to a nice, clean number is irrational. That makes sense. So that's something that you might see. Okay, moving on. Next thing is they will get you to calculate percents. And they can get you to calculate percents, or probably will get you to calculate percents all different ways. And the big thing you got to remember when you're calculating a percent is that you really want to get it into a decimal. Put it into a decimal. Okay, and we're going to do it a whole bunch of different ways. But you've got to use decimal numbers when you're calculating percents. So just keep that in mind here, okay? So let me give you some examples here. If they ask for what was 15% of 100, anytime you see the of here, that is going to indicate to you that it's going to be a multiplication type of problem, okay? And what we're going to do is we're calculating percent, so we want to get this into a decimal. 15% is going to be 0.15, right? We always move the decimal 2 places. So essentially the question is 0.15, times 100 equals what? And of course, if you do the math on that, and we've done the math on this earlier, and again, that's why these problems, they're not quote unquote hard, but they're tricky because you don't have a calculator. Can't type it in real fast, you got to work it out. I guess we could work it out real fast, I would probably set the problem up like that. However, you could set it up, in the inverse as well. But basically, 5 times 0, 0, 5. We put the 0 here. 0.1 times 0 and is 0. So if we did our math right, it should be 15,000, and then we count our 2 decimals again. So the answer is 15. So 15% of 100 is 15. That's the way we're going to do that. Now, if they ask for something like, I'll put it up here, what is the percent, what percent, I'll write it all out here, of 15, or I'll put 150, how about that, is 10. What percent of 150, make a bigger number here, is 10? Anytime you see the 10, or the is here, that's going to indicate to you it's going to be an equal. So it's kind of like saying what number, I'll put it right here, n being just, right, variable, what number of, so that's times 150 equals 10. That's the way you're going to set up the equation. Now, to kind of rewrite this, is because it's like an algebra equation, we're going to say, right, we're going to kind of do it like this. So we're going to rewrite it here as n equals, we cancel out the 150, 10 over 150, okay? Then we're going to simplify it, so that would be 1 over 15. So n equals 1 over 15. So that missing number is 1/15, but like we said, we have to put it in a decimal so that we can get a percent. So unfortunately, what you got to do is divide 15 into 1, right? And in order to do that, it's really going to be like this, 1.00, so that we can get that divided out. And if we do the math here, it's going to be 6. So 6 times 15 gives us the closest to 100, which is 90, okay? Keep in mind our decimal is right here, so we'll put a 0 here. So then 90 minus 100 is, of course, 10, and then we add another 0, we get, same thing again, 6 times 15 equals 90. You can see this is going to be one of those repeating sequences again. So really, what's the answer? It's 0.0660. But then the question is, it says what percent, so we got our decimal, what percent of 150 is 10? So the answer would be, we move our decimal 2 places, 6.66%. So that's multiple steps there, but that's how we arrive at that number. So you can see the way we kind of broke it down. So we're figuring out what percent of 150 is 10, 6.66%, okay? So they're going to have you do these all different ways. Another thing they might have you do is figure out the percent of increase or the percent of decrease. So for a percent increase, okay, I'll just kind of abbreviate this, we are going to figure out by writing a little equation here, your new number, and you're going to see how this is going to make sense in a minute, is going to be subtracted from your original number, then divided by your original number and then multiplied by 100. That's your equation for calculating a percent of increase. For calculating a percent of decrease, it's going to be, in a way, the opposite. It's going to be your new number, original number minus new number divided by original number times 100. So you say, well, how in the world is this going to work? Well, let's say that the question is, you have an amount, so an amount goes up from 20 to 50. That's what the question is, and they want to know what percent of increase is that. from going from a number 20 to a number 50, what is our percent increase? If you look at this, you know it's going to be, right, if you doubled it, it would be 40, so you know it's over double percent increase. But we need to know the exact. So, and we're going to use this equation because we're doing an increase, right? So simply we're going to we'll write it over here. We're taking the new number minus the original, and then we're dividing it over the original times 100. Okay, so that's our equation. We want to rewrite that equation to, of course, clean it up a little bit. Times 100, right? Then we're going to simplify. So really it's 3 over 2 times 100, right? And really, if we do the math on that, again, what do we have to do to figure out? We need to get to that decimal that we talked about. We really need to divide 2 into 3. That's going to give us, without going through all the steps, that's going to give us basically 1.5 times 100, okay? And if you do the math on that, it ends up coming to 150. So that is 150% increase. So going from 20 to 50 is 150% increase. We know 20 to 40 was double, so that was 100. So then 10 more above that would be 150% increase. So anytime you look at your answers, and we've mentioned this before, you want to think about the answer afterwards and say, well, does that sound reasonable? Does that sound like it would be 150%? And that indeed does. Okay? So that's the way you're going to do that. If it was a decrease, we don't have to work it out. But if we were going, obviously, from 60 to 25, right, that would be a decrease, so we would use our decrease equation. Okay? So keep that in mind when you're calculating these. Okay, moving on. We are going to figure out how to convert to decimals. So this should be pretty easy because that's basically what we've been doing, is converting to decimals when we're going to figure out percent. So they might just ask you, instead of asking you a question about percent, they might just say, hey, convert to a decimal. That is never going to be super duper hard, okay? Just throw out some number. 3 over 120 is just something I made up, and they might say, hey, we want you to convert that to a decimal. So really all you're going to do is take 120 and divide it into 3. Of course, that's not going to be, 120 won't go directly into 3, so it's only going to go into 300. So that is going to be a 2 here. That's as close as we're going to get, which is going to be 2 times 120 is 240. So decimals right there. So we need to put a 0 right here. Okay. And then what's the closest thing here? The closest thing here is going to be 5. Okay. Because when we do, I need to subtract this here. We're going to get 600. So 5 times 120 is going to be a perfect 600. So if we divide that in, we're going to get 0.025. That's our answer. Simple as that. That's the way we arrive at decimals, right? You're always going to divide the lower number into that upper number, okay? Let's say we go the opposite way, so to speak, and we're just taking a decimal and we're making it into a fraction. So we take a number like 0.05, which we got to remember what that is. That is 0 is in the tenths place, 5 is in the hundredths place. Anything beyond that would be thousands, right? So this would be written, to make this into a fraction, it's actually pretty easy. You're just going to write it as 5 hundredths, right? 5 over 100. That's the way you would read that, right? You would say 5 hundredths. If it was 0.005, it would be 5 thousandths, right? And that's the way we read it. So that's really the answer right there. But obviously we can simplify that a little bit more. So if we simplify that a little bit more, we know 5 can divide into 100 by 20. So the most simplified answer, which is always what we want to get, is 1/20. Okay, so that is how we would write that as a fraction. Okay, so not as hard as it might seem. Okay, moving on here, we are going to convert a fraction to a percent. Okay, we'll go with an easy one first. If we're doing percents, what do we have to do? We have to go to a decimal first. So let's start with an easy one. We know 1/2 is 50%, right? So how do we arrive at that though? We've got to take 2 and divide it into 1. Well, again, that doesn't work. So we have to put our little decimal in here. 2 will go into 10 though. So we're going to put a 5 right here. 5 times 2 is 10. That's perfect, right? There's where our decimal is. So that is 0.5, right? 0.5 converted to a percent, we're going to move the decimal 2 places, right? So that would be 50%. And that's the way you're going to do it. So remember, anytime we have a fraction, we convert it to a decimal, and then from the decimal, we move our 2 places to get our percent. Okay? So that is how we convert a fraction to a percent. And we can do that with any fraction. Another thing you might be asked is you might be given 2 fractions, and the question is, which one of these is greater? Okay, now this is an easy one again because 3/4 is greater than 1/3, but they might give you something that you just, you can't go by necessarily the bigger number per se to figure out, okay, which is greater. So you need to figure it out. How are we going to figure it out? The way I always did this was I convert these to decimals, because if you convert them to decimals, that's going to give you the best indication of which is bigger. So we take 3 and again we divide it into 1. Okay, that's going to give us a repeating sequence here. Okay, basically comes out to 0.3333. Okay, one of those repeating type sequences. What about the 3/4? Well, we're going to divide the 4 into 3. That's going to be 28, 2. Okay, we do the math here. It's 0.75. So then we can look at this and say 0.33 is smaller than 0.75. So definitely the 3/4 is indeed greater. It's not going to be easy fractions like this. It's going to be trickier ones where you're definitely going to have to convert them to a decimal to figure out which is larger or smaller, depending on what they ask. So keep that in mind, but that's the way you do it again. Just convert it to decimal. So you're going to have a lot of questions related to this, where you're converting decimals into fractions or fractions into decimals. It's going to be a lot of this back and forth, decimals into percent. A lot of this again back and forth. So just take some time to do some practice of this. Another thing they might have you do is estimation. This one might not make a lot of sense, but this is something they might have you do. And with estimation, you're basically they're going to give you a number, and it's going to be obviously very specific, real number, and I just kind of made up a number here. So this is 75,782 times 635. And they're going to say, what is the estimation or estimate for these numbers, what's the answer based on an estimate? So what you're going to do is you're basically going to, anytime you do an estimation, you're going to make all the numbers 0 except the very first one. Same thing here. And you're going to ask yourself, do I need to round up or round down? In this case, right, 5 or higher, you round up. So in this case, we're going to make this a 0, 0, 0, and 0, 8. So we're rounding the 75, right, or the 7, I should say, up to 8. So 80,635. So with the 6, we've got a 3 next to it. We're going to round down. or basically just keep it at 600. We're not going to go up to 7. So here again, we're going up to 8. Here we're staying at 6. So it's 80,000 times 600. That's the estimation, okay? Which is, of course, going to be, if you do the math and put in all these zeros, it's 48 million. That would be the estimation. Okay, if you did the math, it's close to that. It's going to be a touch higher, I believe, if you do the math on that. And this is nice because this type of question is quicker. Because to do the long multiplication problem that this would take some time. This one's pretty quick. Okay, so that's what they're looking for if they want an estimation. Okay. Another thing they might have you do, and I wasn't going to necessarily throw up a bunch of problems on this, but they can ask some real practical, real world questions like calculating a budget. Okay, and I've seen some sample questions where they just say, this business has, numerous expenses, and they can give you 4, 5, 6, 7 listed expenses like rent, employee salaries, telephone, travel expenses, whatever, and they're just numbers, right? Could be, if it's a big business, these numbers could be quite large, especially employee salaries. And they're just saying, what's the budget? And those are all expenses, right? So you're just going to add everything up. So again, it's not a hard problem. It's just a matter of going through it all and making sure that you're adding correctly. They could also do something like, there's a party scheduled and a catering company is catering it, and there's going to be 2 choices, chicken and steak, and there's 100 people in the party, just throwing out numbers here, but 50 want chicken and the other 50 want steak. And they can give you prices like chicken costs $8 a plate, steak costs $10 a plate. And they could also say tea's $1, the dessert's $2, what else? Whatever, you could just mix them up. A roll is 25 cents, whatever. And they might say like everybody's going to get a roll and a drink and the dessert. So you're just going to do the math on that. 50 people times the $8 chicken, 50 people times the steak, 100 people times the tea, 100 people times the dessert, 100 people times the roll, and add it all up. So they might ask you stuff like that. Again, it's not going to be difficult. It's just going to take a little bit of time, and you got to make sure that you multiply correctly and then add everything up. So there's a lot of real world stuff like that. They might even ask you questions about like your balancing your budget, so to speak, like balancing your checkbook. They might ask you something like that. Again, the math won't be difficult on that. It's just going through the process. So just keep in mind that you might have those. None of those are meant to be difficult, okay? Most time-consuming thing is just doing the calculation, okay? Another thing they might ask you for is something like square footage. Some companies coming in to do tile, and the question is how, what's the square footage of tile that they're going to lay, and a little bit of geometry in that might look something like this. Just going to kind of make something up here. They might say, I'd thrown some numbers in here. They might say that, it looks something like this, right? 5 plus 5 is 10, so that fits. This might be 3 right here, and we'll say 8. So the way you do that, of course, is you just calculate it. 10 times 8 is 80, so we know that this square is going to be 80 square feet. What about the triangles, though? These triangles are equal in size. 5 times 3 is 15, but this is a triangle, so we have to split it. So that would be 7.5 and 7.5. That's our square, quote, square footage for that. So the answer would be 15, 7.5 plus 7.5 is 15, plus 80 equals 95 square feet. So they might have you do something like that, and again, I would venture to say that's as difficult as it's going to be. You just have to think about it a little bit, but they can have you calculate square footage. Okay, all these problems are very short word type problems, but again, not meant to be difficult. Okay, what else could they have you do? The last thing I was going to talk about today, something that's going to sound really difficult but is actually really easy, is converting Roman numerals into Arabic numerals. You might read it and say, I have no idea. Roman numerals to Arabic numerals, and theoretically you could go from Arabic back to Roman numerals. The way I've seen sample questions is it's usually Roman numeral to Arabic numeral. See, well, what in the world is that? Well, Roman numeral, most of you guys know, right? You know what Roman numerals look like, and we'll give you some good examples here. But Arabic numerals are just numbers, regular numbers. So all they're wanting to do is give you a large, set of Roman numerals and just say, hey, what number is that? What real number is that? That's all they're looking for, okay? So I made up one that gives us a good variety, so we know what all these mean. And that's going to be something like this. I guess we can just do this. Okay. M, D, C, X, X, I, V. So M is 1,000. Okay. M equals 1,000. D equals 500. This would be a plus, sorry, multiplication. So we're just taking 1,000 plus 500. C is 100. X is 10. Another X is 10, so this would be 10 plus 10, so we can just put 20. And you might know this, IV, right, is 4. If it was VI, it'd be 6. If it was just V, it'd be 5. Right, because this we always put as 4. So it would be plus 4. And you're just going to add those up. So that is your Roman numeral right here. Your Arabic numeral, which these are Arabic numerals, but we want obviously the final answer, which if you add it all up, it would be 1624. So that's your answer. Your Arabic numeral would be 1624. So again, what sounds like a really hard question is not meant to be hard as long as you remember what your Roman numerals stand for. Okay? So that's another one in the books here. We're going to do part 3 very soon, so look for that. We got more to come, but for now, good luck and good study.